Hi there. Today's topic from higher end GCSE that's really crucial that we've got a good understanding of as we go into A-level, where it's going to be taken to another stage, is functions. And functions have got a big role to play, especially in the world of computing, where if you give an instruction to the computer, you want to be sure that you're going to get one particular outcome. So the real key thing of functions are, it's not just like a formula, but it's a formula where you can only get one output for any given input. You might have more than one input that gives the same output, but any one input should only return one output. Otherwise, that could have really confusing things on how a program were to run. So let's have a little look. Right, here we go then. So function, any input has a single output. And we've got two different functions here, one called f and one called g. When plotting a graph on a calculator, you may have done this thing where instead of where you've entered a function and then it's plotted it on a graph for you, and you've just pretended that this bit means y. So you might get y equals 2x minus 10. It would plot you the line that you would think of as y equals 2x minus 10. So it gets quite interchangeable in maths using a function or just having y equals when we're talking about these things. One other thing you may have noticed, if I draw your attention over to the right here, this bit here is telling us what the domain is. Now the domain are all the possible inputs, so the things that we could put into this function and get something. And this here means, this funny little E-like symbol means all of the, and this means real numbers. So real numbers are the non-imaginary numbers. So it's pretty much any number you can think of and that you would have heard of up till now. I mean, even something like pi, which is an irrational number, irrational numbers are included because they are real numbers. They're just irrational. They're difficult for us to write down. So off we go. First thing to do, we've got two functions, and the first thing we're going to ask for is this. Right, finding the values of 5 for f and 10 for g. Pause the video, give it a go. All it's saying is, because we've got x in our function there, we're saying we're putting 5 in for our x. So the function of x would become 2x means 2 times 5, and then we're taking 10, aren't we? So that is 10 take 10, which is 0. So that would be the output there. And then for the g one, with having 10 in there, we'd be saying, right, g there will be 10 squared take 9, which is 100 take 9, which is 91, isn't it? Here's our next question, finding the value of x for which the f function is equal to the g1. So pause the video and give that a go. So hopefully what you may have decided to do here was to say, right, function f is 2x take 10. We're looking for the value which works for both of these the same. So you're making a, easiest way to do that is just to make them equal to each other. So we've got 2x take 10 equals x squared take 9, which is now a quadratic equation which we can solve. So to do that, we need to make it all equal to 0, don't we? So x squared, if I take 2x from both sides, I get take 2x. If I add 10 over to here, I get plus 1 is equal to 0. And then to solve that, is it factorizable? Yep, I reckon it is, because x take 1 times x take 1, or another way of saying that would be x take 1 squared, wouldn't it, equals 0. So there's only, often on a quadratic you have two possible solutions, but here we've only got one. The value that would make that bracket equal 0 is x equals 1, isn't it? So x equals 1 is our only solution there. The reason there's one solution there is if you were going to plot the graph of y equals x squared take 2x plus 1, you would get something looking a bit like that, and where it hits the x-axis would actually be at x equals 1. So I'd know that my y thing would be there. And we actually say that it's touching it twice, because you've got the point where it's hitting and then the point where you're leaving, which are the same point, but 2 equal roots is what we call that. There they are. Okay, time to move on. Right, so here's our next question. We've got a function of x, and then take it one part at a time, but pause the video, see what you can do. So start with the black bit, the writing the function in the form x plus p squared plus q. Hopefully you've spotted that this is basically saying complete the square on this for us. So we've got x squared plus 6x take 5, and we're going to complete the square. So we're thinking we're dealing with that. So let's do that. So what we need to do is we need to halve our number of x's, isn't it? And we're squaring that. But then we've got to take away this value squared, because it'll be that much too big. And then once we've done that, all we need to do is expand this. So we get x plus 3 all squared, take 9, take 5, which is x plus 3 squared, 9 and 5 is 14, so that'd be negative 14. So p equals 3 and q equals negative 14. Right, then it says, hence or otherwise, so we can do this another way, find the roots of the f of x, leaving your answer in surd form. So what we've got here is we want to know, when we're finding the roots, that's solving the equation, isn't it, to making the whole quadratic equal 0. So what we could do, it does say hence, so that means using what you've got already. If we said that this was equal to 0, we could solve this equation by adding 14 to both sides. And then we could root both sides. Now that's going to give us plus or negative the root of 14. And this is an important point here, by the way, folks. For functions, and for this symbol, you'd have been told that the square root plenty of times, I'm sure, has got 2 roots, a positive and a negative one. But when you see that symbol, it actually means the positive square root, which is why in the quadratic formula you see, x equals negative b plus or minus the square root of b squared take 4ac all over 2a, because you have to do one and the other one. So the root sign actually means just the positive one. So we need the positive and the negative, which is why I've put that there. And then that's actually got rid of the, don't need that in there anymore, do I? So it's x plus 3, so x is going to equal negative 3 plus root 14, and x equals negative 3 take root 14. And that is the solution to both of those. Now, if you preferred, because it does say or otherwise, you could have put this in this form here, x squared plus 6x minus 5, used 6 for your value of b, used 1 for your value of a, and negative 5 for your value of c, and you should end up with these 2 solutions there exactly the same. But because we've already done this work, it's quicker to do it that way. Right, the final thing. Write down the minimum value of the function and state the value for which it occurs. So that means the smallest number you can possibly have out of that, which is going to be using this again. So if we've got the function is equal to x plus 3 squared take 14. This is a bit like saying what's the point at the bottom, or what is the x value of the bottom of the curve? What's the smallest thing you could have? And it's what you have when the bracket equals 0. So x take 3 makes x equals negative 3 makes the bracket equal 0, and because it's a square number it'll always be positive, so everything else would be bigger than that. So the minimum value of x at which it occurs is negative 3, and the minimum value is going to be 0 take 14 equals negative 14 is the minimum value. Okay, time to move on for our final example. Right, here's our final example. Find the roots of the function equals x, f equals x to the power 6 plus 7 to the x cubed minus 8. Now this is a slightly tricky one. Basically, this is a quadratic, but it doesn't look like a quadratic, or it's very similar to a quadratic, and that's what we're going to do. What we're going to do is we're going to say, notice that x cubed and x to the power 6, if you were to square x cubed, you would get x to the power 6, and that's what we're going to use. So we're going to say let, you could pick any letter you like here, but the usual convention is to call it u. U equal x cubed. And then we're going to substitute into that. So we're going to say, right, so our function is actually equal to u squared plus 7u take 8. And then when it says about finding the roots of a function, if you were doing, if you had y equals x squared plus 7x take 8, we would know that that is a quadratic that's going to do something like this. It's going to be crossing the x-axis twice, and the roots are the points where it does that. Now, because the x-axis is also known as the line y equals 0, all we need to do is make this equal to 0 and then solve it. So I can say that equals 0. Is it factorizable? Yes, it is, because 8 times 1 is 8, and the difference between 8 and 1 is 7. So we've got a mixture here because we're going to try to make a number that multiplies to make negative 8. So if I go positive 8 and negative 1, 8 take 1 is 7. So that's going to give me 7u. So u equals negative 8, or u equals positive 1 to make those brackets equal to 0. But we needed to know what the x values were, because our graph isn't going to look exactly like that. So we're now going to plug these values back into here. So we can now say x cubed is equal to negative 8. So x is going to be the cube root of negative 8, which you can do in your calculator if you want, but it's negative 2 because 2 cubed is 8, so negative 2 cubed is negative 8. And the other possible thing is that x cubed is equal to 1, and 1 times 1 times 1 is 1, so the cube root of 1 is 1. So x equals 1, x equals negative 2 are our roots. Right, here are your practice questions for today, quite a few of them. I want you to find the roots of all the following functions. Slightly different question at the end, so pause the video now, because in a few seconds the answers will come up, and I'll talk through one or two of them in a little detail. Right, so here's the answers, so take your time, maybe pause it, check through all the ones that you've got right. I'm going to go through question 2, then I'll come back to 1 or 2 that may have caused difficulties. So for this, because A equals 8, sorry, I think I've put down something slightly wrong in that question. That should have said the f of A equals 8. Really sorry, so you might want to pause the video and give that a go. Have a think about what that means. So A doesn't equal 8, the function of 8. So we're looking for the value that you put into there that would return 8. So what we need to do is write that as a quadratic equation where x squared take 2x is equal to 8. And then we've just got to solve that. So if I take 8 from both sides, I've got that, and all I need to do is factorize that. So what are we looking at? We're looking at 4 times 2 is 8, 4 take 2 is 2, so it's plus and minus, it's plus 2 and take 4, because we're summing to a negative, the bigger one must be a negative. Therefore, negative 2 and positive 4 would be there, so A is going to equal negative 2 or A equals positive 4. Right, now coming back to 1 or 2 of these other problems that we've got up here. I thought it'd be worth talking about this one here, because you've got, remember, all we're looking for is the values of x that mean this expression returns 0. So this is a number, x plus 5 is a number, x plus 7 is a number. Just think of it as 3 numbers multiplied together. If any one of those 3 numbers is 0, then the expression is worth 0. So if x is 0, that will be 0. So whatever that comes to, times it by 0, you get nothing. Then if x is negative 5, that's because that bracket is equal to 0. And if x is negative 7, that bracket is equal to 0. So that's why we get those 3 answers. So when it comes to this one here, we're trying to get it into that form. So if we factorize it by taking out the x of both of them, we would get x squared plus 5x take 24, and then all we've got to do is factorize that bit there. So 3 times 8 is 24. If I have x plus 8, x take 3, 8 take 3 is going to give me the 5x, that'll be there. So there's my x equals 0, there's my x equals positive 3 to make the bracket 0, and there's my x is negative 8. Right, then coming down to just finish off with, let's have a look at this one, because this is kind of strange, isn't it? What do we do here? Well, we've got no squareds going on, but this is the square root of that. So if we said let u equal the square root of x, then mx is going to be, that would be u squared, wouldn't it? Because the square root squared gives you just what it is. So u squared take 7u plus 10. And then all you have to do is factorize that. 5 times 2 is 10, and it's 2 negatives. 5 plus 2 makes 7, so it would be that. And our values of u would equal 5, or u would equal 2, wouldn't it? But we want to know what x would be, and as u is the square root of x, then if we squared that, x is going to equal u squared, isn't it? So x is going to be 5 squared, and x is going to be 2 squared, which is why we've got 4 and 25 as our answers. Right, I hope that helped everyone. Cheerio then, folks.